Hello there guys, welcome back or welcome if you're joining us for the first time. Talking about dose response relationship and talking about the potency and efficacy of drug. First off, what is potency? Basically, it is the affinity of a drug to a receptor, the strength of a drug receptor interaction. It is dependent on EC50. So an increase in EC50, meaning a reduced potency. How can we explain this? Let's use this graph. We have a graph of response to drug dose. Now, you give a drug. They start binding to receptor. You have your stage one, the drug immediately the graph start rising. At stage two, you are binding to let's say 50% of the receptor. This is stage two. Then stage three, you're binding to all the receptors. That's how you get this sigmoid graph. And potency is the amount of drug you need to get to 50% of your maximal effect. Now, this drug needed only one dose. This one needed two doses. This one needed three. So this drug has a better potency than this one. But if the drug has high affinity, it needs less of it to bind to the receptors. This one needed more drugs to bind to the receptors because its affinity with the receptor is lower. So the lower the affinity for the receptor, the more drug you need to bind to the receptors. What about efficacy? Efficacy is the drug receptor interaction itself, meaning how many receptors the drug occupies. It's different from the strength of a drug receptor interaction. This is just how many receptors the drug occupies, and also the drug's intrinsic activity. Now again, the sigmoid graph. You see, drug black had a maximal effect, which is 100%. But this one had a maximal effect, but it's not 100%. And drug blue also has a lower maximal effect, which is nowhere close to 100%. What's happening here? Well, it can be two things. Either drug blue and red are not occupying as much receptors as drug black, or, as I see here, drug black has a 100% effect on its receptor. But drug red has 30% effect on the receptor, and drug blue has 50%. So even if drug red and drug blue occupy all the receptors, they cannot produce as much effect as drug black because the effect on each receptor is not 100%. It's either 70 or 50. Now let's say a real world example. Torsemide versus furosemide. Torsemide has the same potency. So it has a higher potency than furosemide. It binds to receptors much more easier than furosemide. Both of them are loop diuretics, but this one has a higher potency than furosemide. But both of them have the same efficacy. Both of them will get to 100% maximal effects, despite the difference in potency. So a drug can have the same efficacy, but different potency, or different efficacy and the same potency. As you can see in this graph, all these drugs here, they have the same efficacy, but the difference is the potency. But this graph here, they have the same potency, but different efficacy.